In this ClimateGenn episode, I'm speaking to Professor Peter Wadhams from the University of Cambridge about his recent research for a book he is writing on the viability of greenhouse gas removal from the atmosphere. Some of these are also called negative emissions technology, or NETs, and are widely included in national emissions reduction plans, despite none being proven at scale today. We discuss the viability of various proposed techniques, including tree planting, bioenergy capture and storage, as well as direct air capture and ocean proposals, including farming kelp and the use of diatoms for large-scale sequestration. In the last segment, we discussed the risks posed by Arctic methane releases and two proposed techniques for dealing with a potential methane emergency, whereby multiple billions of tons of the potent greenhouse gas are released at once. These are controversial proposals, despite policymakers assuming they will work in the future. The danger of these suppositions is compounded by the fact that many research projects are embryonic and underfunded. Thank you for listening. In the next episode, I will speak with author Professor Tom Rosenstiel about his new political thriller, The Days to Come. In this interview, we discuss fiction writing and journalism, as well as how both of these intersect with reality and shape our world. You can subscribe on all major podcast channels or YouTube, and you can also support my work via Patreon. Visit gen.cc for more information. Thanks for listening. Peter, it's good to see you again. You've been doing a lot of work on greenhouse gas removal. This is a fraught subject because it has biases, it has bad press, there's a lot of hope involved in it, and yet there's a lot of people saying it's a sham. We're currently at 1.1 degrees C and pumping tens of billions of tons of greenhouse gases into the atmosphere. And we're already seeing now how disastrous this is all turning out. Is it really feasible, and what's your position on, should we be really pursuing this?
We have to pursue it. I mean, we're not doing so at the moment, and one can see that from the one truthful graph in the whole universe, which is the Mauna Loa CO2 level graph, which is continuing to show exponential growth in carbon dioxide, which means exponential growth in global temperatures. That's the curve we've got to turn, and we haven't done so, and even the Paris Agreement didn't even produce a little blip in that curve. So that's the challenge, and we can't just not do anything, because if we don't do anything, it'll just go on exponentially increasing, and we'll get more and more, not just warmer and warmer climate, but we'll be passing more and more tipping points, which will be giving us unprecedented horrors, like all the horrors that are coming from weather events. They didn't start until about 2005. We never had weather events of that magnitude, and clearly that was now being shown. That's due to the jet stream breaking up. And so here's a phenomenon that never happened before, the effects on the jet stream, but it's happening now and will be happening to a greater and greater extent in the future. So those are the things we have to look out for, and we can't just not do anything and let nature take its course, because it's not nature anymore, it's us. So we have to do something, and the problems are, what the IPCC recommends is purely reducing emissions, and I think that is completely pointless. And since carbon dioxide stays in the atmosphere for thousands of years, then everything that we release from our fossil fuel burning activities stays in the atmosphere, increases the CO2 level in the atmosphere, and it keeps getting warmer. So if we become much more careful and release less carbon dioxide, and then we feel all good, and we feel, wow, we're reducing our emissions, aren't we good? But we're not doing anything to reduce the temperature of the planet. It's warming, it continues to warm up. So it's as if we've put something in the oven and it's cooked and now it's burning. And instead of turning the oven off, we turn the oven up but only a little bit. And we expect that the thing that's burning will stop burning, but it won't.
If we're talking about a safe concentration, an atmospheric concentration of greenhouse gases, and let's say in terms of CO2, we talk about 350 parts per million is a figure that's often used as a safe example. We're miles away from that now. And to get to that, billions and billions and billions of tons of carbon dioxide would have to be taken out of the atmosphere. A lot of people are planting trees. Part of the big effort seems to be around tree planting. Can that get us there, in your opinion, or from what you've researched?
Well, no, I don't think it can. I was looking at some data from Europe, and I think they concluded that if you want to take out 8 gigatons a year, which is only about a fifth of what we're putting into the atmosphere, but you want to take out 8 by trees, then you need 6.4 million square kilometres of trees to remove 8 gigatons per year. Now, if you look at what is 6.4 million square kilometres, it's the entire area of Europe. And 8 gigatons a year is roughly the CO2 production by Europe. So if we want to offset what Europe is producing in carbon dioxide, we need to have the whole of Europe as a forest and nothing else there, no cities, homes, factories, nothing but trees. So we want an Amazon jungle untouched by Bolsonaro, occupying the whole of Europe. We can't do that. So it's always good to plant trees, and it's also good because you feel good. But it's not good in that it's not going to solve the problem. It's not going to get rid of anything near the amount of CO2 we've got to get rid of.
Is there anything we can do with bioenergy capture and storage, or BECCS, which is, it's already in use and has its supporters? What's your position on BECCS?
Well, it's very complex because people keep coming up with new approaches and new methods to try to make it work. But I've been looking at the background, and firstly, it's not quite as bad as tree planting in that the process of growing biomass and then burning it and then converting it into getting rid of CO2, it turns the same analysis that was done for trees shows that to get rid of 80 gigatons of carbon dioxide a year by BECCS, you require something like 2.4 million square kilometres. So it's slightly less than half the area of Europe, which is still a lot and still not really achievable. And plus it has downsides all over the place. And one of them is the fact that you're having to use water and use fertiliser to grow whatever it is you're growing to turn into the carbon capture subject. And that could cause more damage than trying to get rid of it in the first place. So people have been looking at the downside and realising that's just very, very negative and making BECCS very difficult to enact. Also, the fact that the best kind of material to use is biomass waste. So it's waste from agricultural production. But there simply isn't enough of it to be the sole source of carbon dioxide removal. We don't produce enough of such waste. And so we'd have to grow biomass specially to waste it. So we're growing it with fertiliser and water, and then we burn it. So the logic is something that escapes me.
You're researching and writing a book on this at the moment. Have you identified viable options?
Well, there's one that's the obvious one, and there's a couple of others that I think really need to be looked at. The obvious one is direct air capture, because if you're saying, well, greenhouse effect is happening because there's too much carbon dioxide in the air, what do? Let's get rid of the carbon dioxide. And so how do we do that? We do direct air capture. We run the air through a solution which absorbs CO2, and then we find a way to do something with that absorbed CO2, either pump it underground or turn it into some useful product, like the Americans tend to do, which is turning it into limestone, turning it into biofuels. That seemed in the past tense to be the obvious way to do it. And In fact, the companies that have achieved most in CO2 removal are the companies that have just done just that, like the organisation in America that turns it into limestone and then grinds up the limestone to make sand and then uses the sand to make cement and concrete. It gives you carbon negative cement, which is certainly a product worth having.
So you think that that is something that has the potential to go to scale? It must be done in a tiny sort of scale at the moment compared to the challenge. I mean, how do you even scale up something like that, and how long does it take? These are the kinds of things you're looking at.
Yes, all these things take too long. Well, they're trying to scale up by working in association with cement companies, because the view is that if we can produce carbon negative cement, it could become the cement. There's 42 gigatons of CO2 we're putting into the atmosphere, and if we can find a way to take out 42 gigatons, then we're ahead of the game. And the only product where the world needs 42 gigatons of it per year is cement and concrete. If we can turn carbon dioxide into cement and concrete via these processes, then we can scale up and we can actually get rid of the quantity of CO2 that needs to be gotten rid of. So I think that's very promising, and the people who are doing it are very devoted, and they're growing quite fast because there's quite a lot of support in the US for this sort of thing. I mean, let's go ahead on something that we know works. So I'm quite hopeful about air capture, but there has been negative publicity about it, and recently, and you wonder, to what extent is that real? To what extent is it some product of the fossil fuel industry doing something malevolent? But it does cost, and then there's an energy cost involved in removing CO2 by direct air capture. So you don't want to do it using fossil fuel products to power the system. You have to go to places where there's energy available for free, like the pilot plants in Iceland, which use geothermal power, or the pilot plants in Canada, which use hydropower. It is specialised because you have to find a free source of energy to do it, because it costs a lot of energy. So the objections, insofar as they're valid, are that maybe we don't have enough free sources of energy in the world to do the job at the scale that we need to do it.
But it does sound like there's a natural boundary to scaling up if it's the energy issue. I mean, we need energy for other things as well. Is it viable that we just start using renewable energy or clean energy for just removing carbon when we could be helping people adapt? Or do you see that as a real stumbling block, or is there another form of direct air capture that you've identified that could be better?
Well, I've been looking at what that sort of thing might be, and in fact, the founder of Blue Planet, the company that's most successful, said that I was talking to him last year, and he said, "Oh well, if I were starting again, I wouldn't take carbon dioxide out of the air; I'd take it out of the ocean." Because ocean removal of CO2 can be done at a lower energy cost. And you take it out of the ocean and carbon dioxide comes out of the air automatically to balance. And so CO2 that's emitted goes between the two.
Can you quickly give a quick overview of that relationship between the ocean and the atmosphere in terms of balancing carbon? Because I think that's not that widely known, is it?
No, I mean, that's why when people thought about taking CO2 out of the air to bring the CO2 level down, they only thought about taking it out of the air. They didn't think about taking it out of the ocean and then the air gives up its CO2 to the ocean. But that needs another level of thought, but it is possibly a viable method. And not only that, but there's much more ocean around than there is land. So if we're going to build systems for taking CO2 out of the ocean or the air, if we can find a way to take it out of the ocean, there's a lot more ocean available than there is land.
So really, you're talking about a system of carbon sinks. The oceans are obviously very contentious when you start fiddling or talking about fiddling with the oceans. Is there any research or any indication that it's safe or unsafe, or what? I mean, what's the status quo on trying to intervene in the oceans?
Well, at the moment, it looks quite promising. I mean, there's the obvious simple things are floating solar, where you just have large floating field of solar energy. And they're doing that in Norway because you can't really do solar farms because there's not much flat land in Norway. So you stick your solar farm on a kind of giant floating raft and you've got then floating solar. But I wouldn't count that as being something that's normal. This is for a country with an abnormally small amount of flat land. But the two that have been really pushed, I think one of them might work. One of them is seaweed. And if you saw that very wonderful film, Ice on Fire, produced by Leonardo DiCaprio, he shows a seaweed farmer in the northeast US with great big ropes full of gigantic kelp, which he's hauling in, and says, well, look, gee, I don't have to put any food in, I don't have to do anything, I just sit here and the kelp grows on the ropes, and there we are. You just then bury it, and there you are, you've got kelp. But looking at that, what it seems is that the productivity of kelp is kelp mats is only about 1,000 tons per year per square kilometres. That's not going to solve the world's problems. And in fact, it's even less good than abolishing bottom trawling. Bottom trawling, where you take everything out of the seabed in order to produce stuff you feed to salmon farms. That's been calculated as putting in, 1 billion tonnes of carbon dioxide a year into the atmosphere. And if you could abolish bottom trawling, you'd be taking out 1 billion tonnes of carbon dioxide a year, which is more than you can achieve by 1 million square kilometres of kelp farms. So there's a lot of things you can do in the ocean that are more productive than growing kelp. I mean, sadly, because it looks impressive. It's big and fleshy, and you sort of think, wow, this is solving the world's problems. But in fact, the thing that looks like it might solve the world's problems is the opposite end of the size spectrum. It's diatoms, which are about sometimes too small to see with the naked eye, that are the basis of phytoplankton in the ocean. And it turns out that by feeding the right nutrients into seawater, which has got particular kinds of diatoms predominating, you can kill the diatoms by feeding them to death. Then they die and they sink down below the level in which they can contribute to the world's energy system. And you've got a way of getting rid of carbon dioxide. And of course, people don't believe that's possible because these things are so tiny. But let's remember that the biggest whales in the world get to be that big by eating diatoms. You're dealing with something where the mass of diatoms in the ocean is gigantic. So there's a couple of places, well, there's a lot of places which are working on this, but two of them I know about. One is here in Turin at the Polytechnic, where there's a research project on specifically targeting particular diatoms, feeding them and removing them from the system. And that seems to be working very well. But of course, there's a scaling problem. How do you turn this into something that you can operate on a global scale? Another method that's being used is, again, on a much smaller scale, is in Britain, a company called Bear Native, which I got to hear about, and I think they're doing brilliant work. They're in Colchester. They're very close to us. Us meaning me when I'm in Cambridge. And Bear Native is actually, it sounds like a porno film company, but actually it's a species of oyster. It's the species that was used by the Romans. And there's massive mountains of oyster shell, some of them left over from Roman times, dotted around East Anglia. And you're not allowed to throw oyster shells away because there's a bacterium that develops on the shell and will kill off living oysters if you put dead oysters in the sea. So there's masses of oyster shell. And their idea is you turn this into a slurry and you feed it as one of the feedstocks for particular kinds of diatoms. And the ones they choose are the ones that are at the moment causing most damage to lakes. So they've been working in China with bioremediating lakes by putting powdered oyster shell into the lakes, and they find that this works. And it must work because the Chinese pay them lots and lots of money to do this. So at the moment, they're trying to see if we can get some I'm helping them here, see if it's possible to get some support to do this on a larger scale. And they've approached Cambridge Carbon Repair as to be a possible partner in that.
How do you quantify that? I mean, if you're going to try and scale it, how do you know what you're doing in terms of how much is being sequestered?
Well, it is difficult. When you pump air through an air capture device, you can calculate how much carbon dioxide you're getting rid of. And everything involves that kind of calculation. But this diatom removal is something where you need to sort of understand the biology of how particular species of diatom, of which there's thousands of species, how particular species respond to particular degrees of feeding. So it's one of those messy, we are physicists. And when you're a physicist, you sort of think about everything that biologists do as being very, very messy. And you can't really wade through it all and get to some solutions. And of course, that's true. But at the same time, it is actually the most important thing that there is. And it is potentially a way of getting carbon dioxide out of the environment, in this case, out of the ocean, in a way that works. And so I'm quite hung up on diatoms.
So you're bullish on diatoms. But let's say this is a complete fabrication, but let's say, for example, in the Azores or the Canary Islands, they said, okay, we're gonna deploy this over a large expanse of area, and they did it. I mean, what would you expect to be the outcome beyond sequestering carbon, and what sort of scale of ocean would you see as a good test case?
Well, it'd have to be quite a large area, a few thousand square kilometres.
A few thousand.
Yes, if you really want to see a big effect. But what kind of bedevils it all is the work that's already been done in a different way by people like Russ George. That is, you seed the ocean with iron powder. And in many parts of the ocean, the nutrient that's most deficient is iron. And so that's why you get much more plankton growth in parts of the ocean where you're downwind of dust clouds coming out of Africa, for instance, because they carry iron. So iron fertilizes the ocean, and that's something that's been done deliberately in order to increase plankton production and therefore fish production. And that was successful in the effort that Russ George made to increase salmon production in Canada. But the trouble is, this diatom removal is a completely different process. You are feeding diatoms, but you're not feeding them with something that's going to make them grow because they're short of iron. You're feeding them with other nutrients. And it's going to be a different set of nutrients for each of the types of diatom you want to get rid of. So it isn't easy to see. You have to go and study the area, study the distribution of biological material in the area, and then see what is going to be your target phytoplankton, the target diatom, and what is the nutrient that you're going to hit it with. And so there's lots and lots of research needed.
So it has to be tailored to a specific region. One of the things that we're hearing a lot about at the moment is methane levels rising in the atmosphere, and places like the Arctic, which are flipping from a sort of cold area to pretty much a thawing area, releasing ever increasing amounts of methane, which has a lot of people very worried. Is this something that is on your radar? Are you worrying about methane? Are you looking at ways that it can be tackled?
Well, very much, yes, because over the last few years, I've been working a lot in contact with the Russian group that's been doing all the real practical work. That's Natalia Shakova and Igor Samiletov. They go out every year into these East Siberian Sea and detect increasing quantities of methane coming out of the ocean into the atmosphere. So I think it's a real threat, and potentially it's one of these tipping point threats. We're used now to having these dramatically awful weather events every year, either of heat or cold or hurricanes or whatever. It's horrible, and it never used to happen before. And that's because we passed through a sort of tipping point of warming, whereby the warming of the Arctic atmosphere brought its temperature up close to the tropical atmosphere, and that messed up the jet stream and gave us this extreme weather. So in a similar way, this could happen with methane, or not similar, but related way, in that at the moment there's an equilibrium whereby the massive quantities of methane that are contained in the sediments under the Arctic shelves of Russia is held in place by an overlying layer of permafrost. Now, that's been there since the last ice age, and so long as it's there, then the methane stays in place. But methane in the form of methane hydrates is highly unstable if you're in shallow water, which we are. So if you take away that protective layer of permafrost, there's nothing to stop that methane from turning back into gas and coming out in a gigantic burst. And it would be a gigantic burst. And as far as I can see, that's going to happen as soon as the permafrost layer comes off. And it's doing that because of the fact that the sea ice is disappearing and the coastal waters are warming up. So every year you have temperature rises in coastal waters up to maybe 11 degrees. The coastal waters melt off a layer of the permafrost, and already certain amounts of methane find their way out through gaps there and come out as plumes. But there will be a point not long ahead when all of that permafrost will be gone, and then all the methane will come out in one terrible, great burst. That's the tipping point we really should be afraid of, and it's close in upon us. So the only way around it is to try, as an emergency measure, to find ways of getting rid of methane out of the atmosphere or out of as it emerges from the ocean, and take that very, very seriously. It's not simply to keep the level of methane down relative to the level of carbon dioxide. It's to deal with a potential emergency, which would be a methane outbreak.
And is there anything thus far that looks like it's viable for that?
Well, yes, but the research hasn't gone that far forward on it. The one that people think of as most potentially effective is called iron salt aerosol, because it's found that ferric chloride reacts with methane and gets rid of it out of the atmosphere. So the idea of iron salt aerosol is to form ferric chloride powder into kind of aerosol, blow it over a surface where methane is being released, like a methane vent or a methane sort of plume, and get rid of the methane that way. Ultimately, you might be able to do it in normal atmosphere, but it seems a bit wasteful. If there's places where there's concentrated methane, you can work on it better. That's the hope. And experiments have been done in Copenhagen on that, and it seems to work. But not only is it not being scaled, it hasn't been scaled outside the laboratory scale. And if that's going to be the way of dealing with methane, it's got to be massively scaled up. There's another way that was dreamed up, which I don't know what to think about, called floating flakes. And this is a guy from Australia. And the idea is that the Far East is actually there's mountains of rice husks around because rice growing, and the rice husks will float. And what they want to do is to coat the rice husks in something that's rich in iron. For instance, there's a kind of mushy mud that you get from aluminium production. And these floating flakes will then float around in the ocean, absorbing methane because they've got a ferric substance on them and they're floating. So it could be the answer, but what you're likely to get is gigantic, great masses of floating rice flakes, which will get herded together into, and it won't stay as a nice uniform covering.
From those two proposals, then, you would say that the iron salt aerosols was probably more of a goer than the rice husks.
Yes, I would say that it is. And the next stage with iron salt aerosol has to be to test it on a bigger scale. And the ideas that have been suggested are really to pump it out of ships' funnels, to have it injected or into the funnel, into the flue gas, and then use that to destroy methane wherever you go. You could have all the ships in the world could be cruising around the world ocean, removing CH4 as they go. And I think that's an attractive idea and would like to see that pursued.
Okay, so this is obviously an area that is ongoing, underinvested in, and just absolutely critical. I mean, one of the big problems we have is that all of these assumptions of what will be done are embedded in the reports that find their way to policymakers. And yet we're not actually doing any of this stuff. It's all science fiction at the moment. Do you realistically see a point where we're going to be doing this at scale?
Well, we have to reach the point where we're doing things at scale because there's no alternative. First of all, everybody will be scurrying around trying to reduce their emissions and failing and wondering why they can't reduce their emissions because you can't. And then they'll suddenly realise, help, we've got to do something else. And then they'll be going for solutions for carbon dioxide removal that will work at scale. But by then it may be just too late to actually do it because of the mess that's created by having high CO2 levels. It may be something where we simply can't deal with it in time before the world collapses. I mean, if we don't do anything, there's going to be a collapse. And the collapse could come in lots of different ways. One of them could be that just one possibility is the massive numbers increasing numbers, in fact, of weather events that cause huge flooding and disasters is something that can't be handled by the insurance industry. The insurance industry will go under and you'll then have a financial and economic collapse of the whole world because there's no insurance industry left. That's the kind of thing that could happen. And the collapse could be such that with all the best will in the world, we don't have enough time or energy or industry left to enact any of the solutions I mentioned today. I mean, these are all solutions which I think would work. Air capture works, this diatom ocean capture would work. All of them would work, but you have to actually put something like the Manhattan Project into it. You have to do massive amounts, making it the biggest project in the world. Then you can do it. But if you don't, if you just mess around with experiments in the lab and you don't fund it, you've had it. By the time the world really needs it, it's not there. And then we've had it.
Well, I think that's the perfect place to end this discussion because we really are at that crossroads, aren't we? I mean, that is it. Okay, so thank you very much. It's been fantastic to speak to you and very interesting. And I'd love to speak to you again when you've finished the work. Thanks again for listening. If you are interested to help support this series and help expand the discussion around climate topics, then please do consider backing my channel via Patreon. It will help me produce more content and you will also gain access to more expert interviews. It would be great to engage more with audiences too and understand your views on these topics.